everyone. And, a bunch of good questions. And there was one clarification question that I got during the break that I want to highlight for everybody quickly before we do the example. It still concerns this picture. And of course, there's a bunch of questions that you could ask, and a few of them were asked about this picture during the break. But there's one in particular that I want to touch on because it could be a source of a lot of confusion. Somebody asked about CCNR and how is CCNR different from the content store that I talked about in CCND, and is CCNR required versus CCND? So first of all, on the required part, CCND is the most fundamental piece that's required in order to have CCN communication. So we basically think of it as every node has to have a CCND. And that is because it does the packet forwarding, that's what actually gets communication happening. In that sense, the CCNR is less critical than the CCND. It's not required. You can run a node perfectly well without running a CCNR. And in fact, in the first examples that we're going to show, we're going to do exactly that. There will be no CCNR, or if there is, it's incidental. So we're going to run a situation where an application itself is going to be the source of data that we want. And as long as you have an application that's willing to be a producer of data, and an application that is willing to be a consumer of data, communication can take place. So in that sense, CCNR is not as critical. Now, why do we show CCNR here and talk about it in the docs as being important? It's because for many, many real nodes and real practical application scenarios, you have some need to have some local storage to keep just things that you need to remember about the state of your application, maybe keys and things like that. And for that reason, we expect that many, many deployments are actually going to have a CCNR with some local state that is saved here, but that doesn't mean you have to have it in order to run. You have to have the CCND basically in order to run. Now that comes down to the first part of the question, which is about what's the difference between the content store I talked about here and what CCNR, a repository, does. And the difference is that the content store in CCND is it functions just as a cache. It's transient memory. If the node restarts, if you restart the CCND, whatever information you had there is gone. In contrast, the CCNR and the idea of a repository, as we have used the name of the CCNx software, is that a repository keeps data packets persistently in stable storage. So the CCNR in particular that's in CCNx distribution, that program is disk-backed. It actually saves away the content objects that it stores onto disk. So if the CCNR process goes away, if the node restarts, all of the content is still there. So CCNR is about persistent, long-term storage on stable storage, and the CCND is about transient, cache-like memory in the process of communication. If you want to think by rough analogy to what a router might be like, think of CCND as the forwarding plane of the router, having buffer memory, and think of CCNR as being off the forwarding plane, but it might be what you could imagine like a storage card in a router that has a bunch of SSD that can persistently store content. And so it might be actually the implementation of a larger cache that's different than the buffer memory forwarding plane. Good question.
I assume that this is a diagram of a node. Then this CCNR is 1 to unit, or for each application you have one CCNR?
Sorry, not for each application. You see in this picture of a node, you're right, this is a picture of the node. And you see we've got a couple of applications, plus in fact, this is sort of an application at this level. We've got a couple of applications and only one CCNR. So just as there is one CCND on a node, there's very likely to be one CCNR. There could be multiple ones, perhaps each handling different namespaces of content, but there certainly doesn't have to be one per application.
And then when one application wants to request something, it's going to check CCNR first, maybe the other application generates that. Or
no, so what applications do, as we'll start to see, is they ask for data. They send out an interest. And The idea of NDN communication is that it's the network's job to satisfy that interest. It is not the application's job to know whether there's a repository or there isn't a repository, whether the data might be in the repository or it probably won't be in the repository, whether the data came from another app on the same node or it came from an app on a different node. None of those things are supposed to be the job of the application. The application asks its question to the network, and the network gives it data, if it is possible to do so. Now, when we think about implementing the network, of course, the network has to have a way to do that, and that comes into populating the FIB so that the CCND has an idea of where to forward that interest that might find the data. And that gets into both issues of routing and issues of registration for the local apps, so that a local app can say to the CCND, here's a prefix for which I have content, which allows it to set something in the FIB so that when an interest comes in, it can forward it appropriately. But think of all of that stuff as operating at how the network functions to get you the data. And the applications don't know about nodes, about repositories, about CCND caches, none of it. They just ask questions.
You said that CCNR is responsive and application, we want to store a file, a whole file in the CCNR. So, but for CCND, it's a trunk level. I mean,
yep.
you need to split the file to many chunks in the CCNR, and the CCNR may organize these chunks. But in the CCND, it just know one prefix. A short prefix. But maybe CCNR have not all the chunks. And another question is that CCNR can application tell the CCNR how long this trunk can be stored in the CCNR, and the CCNR can responsible for the data. And maybe
yeah. So you're getting to a few different issues there, not all of which I think I'm going to deal with right now. So one of the things that we want to do is get to an example later to show you how exactly it is an application causes data to end up getting to the CCNR in the first place. But to start with the first part of what you were asking, you're absolutely right that what CCNR does is it stores data packets in wire format, named data packets in wire format, so that it can answer interests that come to it later. And as a result, like we talked about earlier, when the app produces some data, by the time it leaves the process boundary of the app, it's already been packetized. It's already a sequence of packets, each with its own name and sign. And in order to simplify that so that every application writer doesn't have to do all of the most inconvenient bits of that, we can imagine the library helps to do some of that by providing things like a stream abstraction or something like a file abstraction. But nonetheless, you're right, that what leaves here and goes through the CCND is individual data packets with individual names, and that's what the repository holds on to. So the way that works is that the application has to cause the repository to be interested in its data, and hopefully this afternoon we'll get to looking at packets that show you how that happens. And then the CCNR starts asking questions to get each of the packets, and those questions end up forwarded to the app, where in the library of the app itself, they actually answer and say, okay, here's the next one you wanted, and then the CCNR holds on to them persistently and can answer subsequent questions. When somebody later asks a question about the same data packet, now it can come out of CCNR. Okay. Let's move on to our first example. So we need to sort of do a little machine switch here to make this happen.
Should reason we're doing a machine switch is I was busy coding while Jim was talking. This may or may not run.
So remember that this is not finished, Bert?